All right, welcome to video number 5. Yeah, video number 5, page 13 onward on UEFN Optimization for Level Design. Let's see here. Bring that down a little bit. Now, please ask questions. Please keep me honest. We're going to go into lighting now. And I'm on Twitter as GameDevMicah, in Discord as GameDevMicah, and on LinkedIn as Micah Berninghausen. Also, go ahead and comment down below in the comments on YouTube for those future viewers will watch and they'll have the same questions you do. Maybe you can answer outdated questions as this video starts to age the minute it's pushed on the internet. All right, let's talk about lighting. Lighting in Fortnite is real time, aka calculated and movable. We are not able to use true static or baked lighting in UEFN, but we can get faster. Real-time lighting is one of the most heavy GPU workloads in a video game and should be reduced where possible, along with shadows and reflections. The UEFN way to reduce dynamic runtime lighting is with the use of mesh distance fields and global distance fields generation ranges. What I mean there is that on your light you can reduce down the distance that you'll cast a dynamic shadow, and then after that distance of dynamic shadows, you'll be using mesh distance fields to cast more static lights at a distance. So as you reduce down the distance of dynamic lights that you cast, the far away light shadows will be done with more statically made items, which is the distance fields. I was unable to modify or create a new world time of day manager. Rather, I had to just disable the settings and put in my own detail. There is a lighting rig you can use to twist those things around, so definitely try the light rig device and see what type of settings you can change there. Try disabling the world time of day managers using your own directional light to ensure you have control over that distance. But those are some of the things we're going to try and look into now in these following pages. HWADs always cast a shadow no matter what's done. So mesh distance fields for distances in the dynamic shadows and HWADs is something we should be using. If HWADs are not used, it will take effect and draw shadows at the max cast distance. So examples are coming. So I'm trying to basically say that to reduce dynamic shadow distance, we must disable and create a custom directional light to gain shadow controls. I didn't see all those details in the lighting rig, environmental light rig, but that's a area to play with as well if you want to use a pre-canned amount of lighting assets rather than doing your own individual components. To disable Fortnite's World of Time a Day Manager is a checkbox you can do. So we can use our own daylight component and navigate your own. To do so, you gotta navigate to the world settings of your island and check off disable all time of day managers. After you've disabled the day manager, your level will now be dark, unlit, and any time of day control will no longer work. So if you're using something to change the time of day. To regain light in your level, you will need to add the following. Add an environmental light rig. It will add the following components to a new blueprint actor and place it in the world, or add these components directly to your world. So a directional light is going to be the main light in your world that does pretty much everything. Exponential height fog is a way to blend the environment's lighting into the darkness of the lower half of the sphere of the world typically. A sky atmosphere will do things like putting some clouds and help further with blending and reflect light and give you that blue skylight. Or matching skylight to whatever time of day it is. And then the skylight itself is a way to try and cast light from another source than the directional light so that you can get some light in your dark areas. A directional light is required. This is the sunlight that provides most of the visual light and shadows seen in the world. This component holds a majority of the shadow and light settings that drive your whole world. Rotating this light can change the direction of the sun in your world. I wonder why these are spaced out like this. Uh-oh. Something's kind of missing right here. These should be up here somewhere. Okay. So on your light, you can still set it to stationary instead of movable. It won't make baked lighting, but it will let some things perhaps get baked. In the Unreal Engine 5 world, setting your light from movable to stationary will let some shadows bake, or rather some shadows not be computed every frame. So I recommend doing it over here unless you're as well. So I would use stationary instead of movable. Light shaft blooms, that's an art direction piece. Not using it is cheaper. So you could disable it if you don't want, if you want to cheapen things up a little bit. Dynamic range, let's see here. I wonder if this is supposed to be down one page. Let's try it. Yeah, it looks a little better. All right, stationary light, oopsie. Stationary for lighting. Light shaft blooms, an increased art direction option. Dynamic shadow range, so cascade shadow maps. This is where on the directional light you can go ahead and start reducing down the amount of shadows you have to calculate. And the range, the dynamic shadow distance is how far out those shadows will be generated, and the shadow cascades is how much compute you're going to be doing to make the light look good. So you can try turning that down from the default of 4 to 1, see if it still looks right, and then the dynamic range, you can try turning that down too. And same thing with the far shadow distance. Light functions. This is where you get the look of shadows on the light, or like without actually looking up and seeing the shadows. Light functions change how light's cast and what it looks like when it's cast. It adds a cost, but it can definitely add some nice look. So I mean, the cloud light function they have on the default directional light is really nice. If you could, and so there's, if you can keep it, that's good. But you might have to make it your own because I can't reference it. But if you copy it over, that'd be cool. But it does add costs. Transitions from dynamic shadows, expensive player shadows. This is where actual movement is involved. Over to field-based shadows, cheaper, at 250 units or 2,500 units. And turning off field-based shadows past 100,000 units. This is what we're doing down below. This means no shadows will be seen past 100,000 units. And this is like this number right here. Far shadows for 100,000. Dynamic shadows at 2,500. So we're going to show how this is actually seen in the world. Right here on these three you'll see below. Only H-LODs and light functions. This means no shadows will be seen past 100,000 units. Only H-LODs and light functions will show shadows out there. No moving or dynamic player shadow will be seen past 250 units unless it's generating mesh distance fields. So these three pictures below. Distance fields fade out at 100,000. So we flew up away from these boxes, and you can see where I have this this red 100,000 drawn here is where the shadows are gone from mesh distance fields. Over here we can see with distance fields enabled, we can see the shadows are all the way out are all the way out here. If we disable distance fields, we can see that shadows stop being drawn at the 2,500 range right here with this shadow on the boxes. What I'm showing is that when you have mesh distance fields enabled out to 100,000, it will provide anything generating mesh distance fields will provide cheaper lighting because it's not as dynamic out at that range. If you disabled mesh distance fields, which we did on the second part here for the static mesh, I said, hey, static mesh, don't generate or don't affect mesh distance fields. It won't provide far shadows. So the less shadows is less is best. So you want to kind of look at your art direction, look at your shadow shafting range, look at your mesh generation fields range, and adjust these so that you still get the visual you're looking for with the least amount of compute. So these are just, this is a high optimization piece here. It's like, where do you care about shadows? How far away do you need to see shadows? And this is more impactful in non-nanite, non-lumen versus lumen. But since that's the Fortnite world, less is best on shadows as well. Setting the mobility type for any mesh to static is a best practice. But I've discovered in UE, it doesn't affect lighting that much since you don't have any static lighting. It will still cache things like collisions by being on something less than less costly collisions caching when you set it to stationary versus movable. So there's a reason to set it to stationary if it's not moving. The mobility setting tells physics. Yeah, so this kind of covers it. Mobility settings tells the physics engines, the collision engines, and networking systems to cache movement and skip work when possible. So it's best to set mesh mobility types or every mobility type to static or stationary when it's an option for those reasons as well. And only mark it as movable if the object is moved within the game code or physics at runtime. There's no physics, so it would have to be something moved by verse. And even then, if it's moved by verse, you might be able to get away with stationary. Other directional light components. Delete where possible, not use. Some UEFN assets, blueprints, or devices come with lights embedded in them that cannot be deleted. So when you're using UEFN props, such as vending machines. To disable these lights fully, uncheck the effects world checkbox, reducing the effect range and also reducing the intensity of the light helps, but the only way to truly disable it is by making it no longer affect the world. And by doing the less lights is best for sure. Even though Mega Lights was just announced, I don't think it's making it into Fortnite. So go ahead and remove lights you don't need. Use emissive materials when you can, if you need just some general add-in, but try to stay away from directional lights, spotlights, area lights, and reduce down their impact and area effect as much as possible. Will help with performance. Exponential height fog, that's an optional piece. We're going through kind of these lighting components. This is fog that blends the world to the sky and prevents large black bars out away from on the horizon. Without fog, rendering FPS will improve. Disable lighting directionality on the fog volumes for cheaper rendering. So anything you don't need, if you disable it, will get a little bit cheaper and faster. It won't impact the package size in these settings, but it will impact the frame rate of your clients when they're playing. The skylight is optional. This component provides additional lights to mimic balanced atmospheric lights, increasing shadow costs if shadow casting. It's faster when disabled. The sky atmosphere, another optional piece. This adds options for clouds and pretty reflective light to mimic the sky and atmosphere. It's costly and can be replaced with a sky sphere and a cheap blue material. To create a new cheap sky actor and make it the class of sky sphere if that's exposed. I was able to find it and place it in your level. It just looks like this: sky sphere. This is just a sphere static mesh that's inverted with inverted UV surfaces. If you cannot find a sky sphere, you could use a double-sided texture on a normal sphere mesh and scale it up. Just make sure you turn off all collisions. Ensure this actor will always be loaded, no spatial loading, and never culls, as we do not want the sky to disappear. Create a new material. You can just a simple blue material, opaque, unlit, two-sided, and not casting ray shadows. And that will be your sky. Just plop that on the mesh and you'll have a blue sky. All right. You could add some simple clouds or not, up to you. If you do, use the ones without collision unless you expect the player to collide with them. All right, let's talk about H-LODs. H-LODs are Unreal's way of streaming in and out items. To reduce down the ISM, or to reduce them down, the visual representation of them down to an ISM or HISM or a merged mesh representation at a distance. This conversion removes all the scene/level devices and static mesh actors and components if they're spatially loaded, replacing them with a generated static mesh or merged mesh or ISMs batched on the GPU. When a camera or player comes within the loading range of an H-LOD, the H-LOD unloads and the device, meshes, and actors are spatially streamed in or created in their place. This is called streaming. Each static actor has an option within the actor component to select if it should be considered an H-LOD generation, and what type of H-LOD generation it should do, and then if it's spatially loaded. You can swap between these options. So you can have an actor that is spatially loaded but excluded from H-LOD. That way you don't have to have it in the merge mesh and cost there, or have it in instances. You would do this for things that are small that you can't see at a distance, like debris or pickup items. And then you would just include things that you would want to see at a distance into the H-LOD The less you can include in HLOD, the cheaper that's going to be, the less data, the better things are going to run. Between the options, none for your HLOD batching policy, that's the merged mesh piece. That's going to create a new mesh, create a new texture, and cost you on your package size and impact your memory performance because you're going to be loading in a new texture and material. Using mesh selection or instancing, both of those will instance all the like meshes together into GPU efficient ISMs or HISMs. So I use the instancing one as much as I can. The larger your cell sizes can be, the more meshes will be instanced into the same actor component, and the more efficient the rendering via instances is. The HLOD merged mesh generations are, I guess we just covered this. None merged mesh, where the highest LOD, so like it could be LOD 5, whatever's the lowest, most simplistic version, will be merged in with other meshes and make a combined, simplified version of it for rendering at a distance. This looks bad up close, so that's where you load in the full actors and stream those in rather than getting up close to the HLOD merged mesh itself. Merged mesh selection instances are exposed on custom meshes only and uses the highest level of detail as well. But if you only have one level of detail, it will use that. When you're using only the LOD 0, then your instances, ISMs and HISMs, will look exactly like your actors do. And so they can be used right up to the camera. In order to use instancing though, your material has to support it. And that's why the default UEFN props that are pre-baked into the editor, some of them don't support instancing. It's worth checking to find out if it does. How would you do that? You would mark the mesh or the actor or the prop as part of HLODs and then check it off as using instancing. Then you would want to go ahead and build the HLODs and find out if it converted it for you. That's the only way I know of, is by using the HLOD system itself to convert all of our instances and into ISMs and check it out. So you just have to see what will work. If it doesn't work, what I've been doing is I'll make a cheaper version of the mesh. Take a square, take some photos of the mesh and just apply them to it, which is what my level's built out of. Just squares with cheap screen grabs of the different needed materials, just as a way of an example. So that's one way to reduce stuff down. So it does require instance-enabled materials to be used, which is a checkbox in the material, so it's not a big deal. HLOD cells and loading ranges. That's what this picture is showing here. So you can turn on preview grids, which we've kind of done before, and that will show you your cell sizes, which is that's 10,000 I have here as an example. This square up here is 10,000. And then with the loading range, this dot is where you are, and it will go up to 5,000 out, which is the sphere that will go around you. That will be your impact. That will be what you're able to load. This one's getting a little bit cut apart. We're going to be in it soon. We're at 18 minutes. So really, this loading size here is interesting. I want to talk about this for a second. When you build your HLODs, you build these instances into these 10,000 unit cells, and then you load those cells in based on if they're within 5,000 units of your player, is how we have it set up for a loading range and a cell size. If you make your cell sizes smaller, then each cell has an ISM per mesh. The chances are, with the smaller the cells are, is less likely you're going to get multiple instances of the same mesh to add into those ISMs. So the bigger your cell size, the more you can use the ISM aspect, and you want to at least get two instances in every ISM to really be better than a static mesh in overhead costs. If you were to say just use one cell for your entire level, load it at 0, and then put in your own collisions, you could use one ISM that represents all those instances across the world. It's pretty efficient. It's what I did do in my level, and that's what I'll show you a little bit later. All right, we're at just about 20 minutes here. And we got a whole bunch of more HLOD stuff to go over, how to look at it. So we'll go ahead and dig into HLODs a bit more in this next video. Thanks for watching.